So let us solve a problem on deflection, examination problem. The problem runs like this. So this is it is a problem on simply supported beam. So he has given a simply supported beam like this. AB is a simply supported beam having simple supports at A and B. It carries two loads 20 kN each at 2 points C and D, and the distances are given like this. AC is 2 meters, CD is also 2 meters, DB is also 2 meters. And of course he has given he has not given anything about E and I. So only thing is you can take E and is equal to constant. What he has asked here is we have to find the ratio of deflection at center of beam, deflection at center of beam to the deflection under any of the loads. It is under the 20 kN load. So here you can see here that he has given a simply supported beam carrying two concentrated loads. If you observe the loading, you can see that it is symmetrically loaded. So this is also 20, this is also 20 kN. If they are acting at equal distances from the support, that means so the given beam is completely symmetrical. So the given beam is symmetrical. So once you can come to know that it is symmetrical, reactions at these two supports will be equal. That means RA and RB, they are the reactions. So RA is equal to RB. So the total load is 20 plus 20, 40. That is equally shared by the reactions. So this is also 20 kN. So you can see that the reactions are also equal and they are equal to 20 kN. Once you come to know that the beam is symmetrical, one important thing is deflection is maximum at the center. This I have told in the beginning class. So center of the beam, I will take it as E here. E is the center of the beam. Center of the beam means it will be at a distance of 3 meters only. This is 3 meters, this is also 3 meters. Totally 6 meters. So deflection is maximum at midspan. Maximum at midspan, or at midspan point is E. At the midspan E. So that means YE is Ymax. So in this case, because of symmetry, of course, and another condition is slope at E, that is theta E, will be 0. Because the deflected curve will be something like this, and if you draw a tangent here to this curve, this theta E tangent will be horizontal, or it is parallel to axis of the beam, so theta E will be 0, and this is your YE or Ymax. And if you consider the other point, what he has given us is, you have to find the ratio of the deflection at center, that means YE divided by YC. Deflection under any of the loads, because the loads are same, either can calculate YC or YD. So YE divided by YC, so this ratio we have to find. So first we will find out YC and then YE, then we will take the ratio. This is the given problem. Of course, EI value is not given, so if it is not given, you can just take EI as constant. So EI value is constant, that's the rigidity value. Of course, this problem is solved once again by using Maclaurin's method. So let us adopt Maclaurin's method to solve this problem. So Michaelis method. So Michaelis method, according to this, we have the deflection equation, which is developed by Euler and Bernoulli. According to deflection equation, bending moment at any section xx is given by EI into d square y by dx square. This is the deflection equation. Now, let us see how Michaelis method is used. So, we have to consider a section in the farthest region. So, here in the case of simply supported beam, x is measured from the left support. I have told you in the earlier lecture. X is measured from A here. That means at A, x is equal to 0. That is it. Here at B, x is equal to 6. 2 plus 2 plus 2, 6. At C, x is equal to 2. At D, x is equal to 4. So now, we have to consider a section in the farthest portion of the beam. So this beam is divided into 3 portions, AC, CD and DB. So from A, the farthest portion is DB. So I have to consider a section XX in the farthest portion, that is DB. Now I am doing Michaelis method. So this distance I will take it as x. So consider a section XX at a distance x from the support A in the farthest region, that is DB region. Now I will write the expression for bending moment at xx, which is denoted as mx, by taking left side. By taking left side of the section, you know that bending moment or shear force is computed either by taking left side of the section or right side of the section. Now I will take left side of the section because distance x is measured from the left side. So bending moment is given by now. If you consider left side, bending moment due to this 20 kN reaction, bending moment due to this 20 kN force, and also bending moment due to this 20 kN force we have to consider. And according to sign convention, upward forces give positive bending moment, downward forces give negative bending moment. Now this 20 kN reaction is an upward force, so bending moment is positive. So plus 20 into moment means it is force multiplied by distance. Distance is x from the section xx to 20 kN is x, 20x. Then come to this load, it is downwards, so minus 20. Distance is x minus 2. Distance from xx to this point C is x minus 2. Then this is also negative. Minus 20 into distance is x minus 4. So this distance is x minus 4. So this is the bending moment expression. So this expression we have to write correctly. So if you do mistake here, further steps will be wrong. So this is the bending moment expression at xx. So now this can be equated to, this mx can be equated to EI into d square by dx square. Therefore what I can write here is EI into d square y by dx square will be equal to 20x minus 20 into x minus 2 minus 20 into x minus 4. So this is, I will call it as equation 1. So this equation is the moment equation. So from the moment equation, if you integrate, you are going to get the slope equation. So integrate with respect to x. Of course, both sides we have to integrate. Integrate with respect to x. So this becomes EI into dy by dx. Integration of d square by d square is dy by dx is equal to 20 into x square by 2 plus minus 20 into, now here in Michaelis method, what we do here is whatever is there in this bracket, the distance is there, distance factor is there, you know, that is taken as a whole and it is integrated as a whole. That means x minus 2 is taken as x and it is integrated as x square by 2. That means here it is 20 into x minus 2 whole square divided by 2. So you should not take the term separately and integrate. We have to treat this as a whole, as x, and integration of x is x square by 2. Like that we have to integrate. Minus similarly here 20 into x minus 4 is taken as x and integration will be x minus 4 whole square by 2 and C1 constant of integration will be added. So this is the slope term. If you simplify this, you will get 10x square minus 10 into x minus 2 whole square minus 10 into x minus 4 whole square plus C1. So this I will call it as equation 2. So first one is moment equation, second one is slope equation or rotation equation. Now once again if you differentiate this, you will get the deflection equation. So integrate once again with respect to x, integrate with respect to x. So you will be getting LHS as EA into y. Y is the deflection is equal to 10x square. If you integrate x square, it will be x cube by 3. Then minus 10 into, once again this x minus 2 is taken as x only. So x minus 2 whole square becomes it is x square. Integration of that will be x cube by 2. That means x minus 2. X is nothing but x minus 2 here. Whole cube by 3. Then minus here also 10 into x minus 4 whole cube by 3 plus c1x plus c2. So one more constant of integration term will come into picture. So this is the deflection equation. So I call this as equation 3. So one is moment equation, 2 is slope equation, 3 is deflection equation. Now next step is to find these constants of integration c1 and c2 using the boundary conditions. Now let us write the boundary conditions here. So in the case of symmetrical beam, this is a symmetrical beam. I have told when I did the first class simply supported beam subjected to UDL throughout, I had explained that. So first boundary condition, there are two unknowns here, C1 and C2. So we have to use two boundary conditions to find those two unknowns. First boundary condition is at the support A. A is a simple support. At A, value of x is 0 because x is measured from A, and the value of y is also 0. Deflection is 0 at the simple support. You can see here. This reaction will restrict the deflection. There is no deflection, only you will be having slope here. So theta A will be there, but Ya will be 0. So you have to use this condition in equation 2. In equation 2, because this is theta, dy by dx is theta. In equation 2, we are going to use that. Substitute this. So in equation 2, so let us see what happens. LHS is EI into theta. You have to substitute in equation 3, not 2. Equation 3 because it is a deflection equation. Y is 0. So LHS becomes 0 is equal to 10 into x is 0. So therefore it becomes 0. First term becomes 0. Minus second term is 10 by 3 into. So another important point you have to consider in mechanics method is, if you substitute for x here and if the term becomes negative, for example here x minus 2 means, in this case it is 0 minus 2, so it is minus 2. So if it becomes negative, then that term is neglected. That is very important. That means here this term you have to neglect because you are getting minus 10 by 3 into minus 2 whole cube by 3, like this you will get. But when you get negative term, this term you have to neglect. So this is very important. So 0 automatically it will become 0. Suppose if any term within brackets, if it becomes negative after substituting for x, then that term is also omitted. Similarly here you can see minus 10 by 3 into x is 0 here. 0 minus 4 is minus 4 whole cube by 3. So this is also negative, therefore this term is also neglected. Neglected means it is taken as 0. Plus C1 into 0, this is also 0, plus C2. That means all the terms will vanish. So what we get is C2 is equal to 0. So this is how we have to do. So this step is very important. So two things you have to keep it in mind in mechanics method. First thing is, so this whatever is there in brackets, x minus 2, it is treated as x and it is integrated. Second thing is, after substituting the value of x either in slope or deflection equation, if that term becomes negative, that term is neglected. So here C2 is equal to 0. So now second boundary condition, since it is a symmetrical beam, in the case of symmetrical beam, the boundary condition is the deflection is maximum where the slope is 0. So here we know that the slope is 0 at point E. At midspan, deflection is maximum, slope is 0. that condition we can use. That is at E, x is equal to 3 meters. Okay, x is equal to 3 meters, but theta is equal to 0. So this is very important. So the slope is 0 at the point E. If you draw a tangent, it will be parallel to axis, theta will be 0. So this condition we have to use in equation 2, because equation 2 is the slope equation. Slope is involved. Substituting this in equation 2, what you will get here is EI into theta. Theta becomes 0 here, so LHS becomes 0, is equal to 10 into, so x is 3 here, so 10 into 3 square, 10 into 3 square, minus 10 into 3 minus 2 whole square, minus 10 into 3 minus 4 whole square, plus C1 into 3, plus C2 is 0. Plus C1 into 0, that's all. Sorry, plus C1, that's all. Yes, this is the equation. Now here also, if you observe, so 0 is equal to 10 into 3 square means 90, minus 10 into 3 minus is 1 square means it is 1, over 10 into 1 is 1 itself, minus what happens here, 3 minus 1, you should be careful here, 3 minus becomes minus 1, 3 minus 1 becomes minus 1, so it is negative, therefore you have to neglect this term because of this term. Okay? After substituting for x, if the term comes out to be negative, that term we have to omit. So this is also 0, then plus C1. So therefore, you can get C1 as 90 minus 10 is 80, so minus 80. C1 is minus 80. So we got both C1 and C2. So C1 value is minus 80, C2 value is 0. Once we get these two constants of integration, now substitute back in equations 2 and 3 to get the general slope and deflection equations. Now what I will do here is, let me substitute those two values, substituting for C1 and C2, substituting for C1 and C2 in 2 and 3, in equations 2 and 3. So EI into theta, equation 2. So I am substituting first in equation 2. EI into theta divided by x over theta is equal to 10x square minus 10 into x minus 2 whole square minus 10 into x minus 4 whole square plus C1 means it is minus 80. So this is the equation. I call this equation as phi. This is general or the final slope equation. By substituting the values of x, we can go on getting the values of theta. Next, substituting equation 3 for C1 and C2. Equation 3 is like this: EI into y is equal to 10 by 3 x cube minus 10 by 3 into x minus 2 whole cube minus 10 by 3 into x minus 4 whole cube minus 80x. C2 is 0, C1 is minus 80. So this is the final deflection equation. So I can call this as equation 1, 2, 3, this is 4, this is 5, equation 5. So equation 4 is the slope equation as the rotation equation. Equation 5 is deflection equation. So in these two equations, if you want to substitute the values of x, you can find out the slope and deflection at the required points. Now here, of course, he has asked the ratio of deflection at E to deflection at C or at D. This ratio he has asked. Now let us find out YE and YC separately. Then let me take the ratio. So to find YE, so here there are two things. First let us find out YE. To find YE is nothing but your Y max here. So to find Y, what we have to do is put x is equal to how much at point E, the value of x is from point A to E is 3 meters. So put x is equal to 3 meters in which equation? In equation 5. Because 5 is the deflection equation. So EI into y becomes YE now is equal to 10 by 3 into 3 cube minus 10 by 3 into 3 minus 2 whole cube minus 10 by 3 into 3 minus 4 whole cube minus 80 into 3. Now here you can see if you simplify this 10 into 9 it becomes. So it becomes 1 3 will get cancelled. It becomes 90 here. So this becomes 90 minus this becomes of course 1. So minus 10 by 3 will be remaining. Here you can see 3 minus 1 is nothing but minus 1 which is negative. So this term we can cancel. So minus 240. So if you simplify this it is minus 150 minus 10 by 3. Right? Minus 150 minus 10 by 3 which comes out to be can take minus 153.33 or in other words YE is equal to minus 153.33 divided by EI. Negative sign indicates that the deflection is downwards. So this is downward deflection. This is the maximum deflection you can have. Similarly, you can find out YC value. If you want YC value, you have to take x is equal to 2 meters. So YC and YD they are same. Whether you take x is equal to 2 or x is equal to 4, you will get the same answer, then you can check it out. So to find YC, so only thing is we need to substitute the value of x as 2 in the equation 5. So let us find out that. To find YC, then we will take the ratio. To find YC, put x is equal to 2 meters in equation 5. In equation 5. So what we can write now? Equation 5, EI into y becomes YC is equal to 10 by 3 into 2 cube minus 10 by 3 into 2 minus 2 whole cube minus 10 by 3 into 2 minus 4 whole cube minus 80 into 2. This is what we get. Here you can see this is 10 into 80, 80 by 3. 80 divided by 3 which is 26.67 minus of course this becomes 0, 2 minus 2 is 0. This is negative, so negative means this 2 minus 4 is minus 2. Negative you can omit that. So only this term will be there, minus 160. So 26.67 minus 160 is 133.33 minus 133.33. Therefore, YC is minus 133.33 divided by EI. Once again, this is negative means deflection is downwards. Now, once you get these two values, you can just take the ratio YE by YC. The deflection at midspan divided by deflection at the node is equal to minus 153.33 divided by EI divided by minus 133.33 divided by EI. The EI will get cancelled, minus divided by and minus becomes plus. So you will be getting the answer as 153.33 divided by 133.33 which is 1.15. So this is the ratio. You can see that maximum deflection occurs at the midspan. This is the maximum deflection. So this is how we have to apply Macquarie's method to find the deflection. Of course, in this problem, he has asked only the ratio of deflections. He can ask slopes also. If you are asked to find the slope at any point, for example, if you are asked to find slope at A, so let me do that also, so that I can understand how to find the slope. So to find, so this is an additional thing I am doing. Note I will write slope or rotation at A, theta A. If you want to find theta A, put x is equal to 0 in equation 4. Because we need slope, we have to substitute in equation 4, slope equation. So here if you put that ei into, it becomes theta a, theta becomes theta a is equal to 10 into 0, x is 0, because at a x is equal to 0, 10 into 0 minus 10 by 3 into 0 minus 2 whole cube minus 10 by 3 into 0 minus 4 whole cube, then minus 80 into 0. So you can see here, I'm sorry, minus 80, this one. Sorry, this is square, not cube, square, this equation. Yeah, here also you can see first term becomes 0, second term this 0 minus 2 is negative, this you can omit, third term 0 minus 4 is minus 4, you can omit this, only minus 80 will be made. So that means your theta a will be minus 80 divided by ei. Minus means it is clockwise rotation. If you get plus, it is anti-clockwise rotation. Similarly, if you want to find theta c, you have to put x is equal to 2. If you want to find theta d, x is equal to 4. If you want theta b, you have to put x is equal to 6. After putting the value of x, if the term becomes negative, that should be neglected and remaining terms only should be considered. So this is how we can find out the slope and deflection by mechanics method. Only thing is you have to consider the section xx in the farthest region, farthest portion. So here AC is one portion, CD is another portion, DB is another portion. So it has to be considered in the farthest region from the point where the x is measured. In the case of cylinder protected beam, x is measured from the left support, whereas in the case of cantilever beam, x is measured from the free end. So this is here are some important clues. And in mechanics project, two important things we should remember. One is this x minus 2, x minus 3, x minus 4, whatever terms you are going to get, it should be integrated as x only. So x minus 2 integration will be x minus 2 whole square by 2 like that. The other point is in mechanics method, after substituting for x in the complete term within brackets, if the term becomes negative, that term should be omitted or neglected, only remaining term should be considered.